Okay, this is less of a tutorial and more of an update and an overview of wave function collapse working in 3D now. So you can see it generated the bottom layer there, and then it's working through the next layer. And then as a final little bit, there's also a recipe checker where it can find blocks and it spawns in a specific blueprint for the block. So in this case, every pillar that has a thing of 4, it spawned in a little orange circle. So I'm going to go through all the things I did to do this. I'm not a programmer. This is not well optimized, but just to kind of document how one could approach this if they're wanting to learn more about wave function collapse. Okay. So to start, we just made in Blender all of these shapes. I think there's about 30 of them. And then what you're supposed to do is write a script in Blender to check and label all the sockets. I did it all by hand though in Google spreadsheets. So this is the name of the socket. There's actually 2 air sockets. I figured this out later on. You're going to want 2, or maybe there's another way around this, because one is an external air and then one's an interior air. And I use those differently. This has the actual mesh. You notice there's 4 what they call prototypes for every mesh. That's for one of every rotation. So the sockets are actually the same. They're all just shifted over by 1, other than the vertical, which is just labeled based on the rotation. I realized also I need a way to label it if it goes on the ground, so that way I can generate the bottom layer first and then the top layer, so I'm not generating like top level pieces on the bottom. And then finally I added in a weight to the tiles. This isn't necessary, but it was anything between 1 and up. You can kind of make one tile prioritize over the other tiles, but it's still being random. Once I had that, then I moved into the Python scripts. With the help of ChatGPT, we were able to write a Python script. I may throw this in the description. And all this goes through. So I exported that document, which is this right here. And then this Python script reads in this document, kind of checks the different rules for what is allowed to socket into what, and then it spits out another CSV file with all these valid neighbors list, is what it's called, for each prototype, which is right here. And this just has the valid neighbor for every single prototype. And then I also wrote just a .bat file to run my Python script. Okay, so I think these are actually the hard parts, is all the sockets, the rules, the valid neighbors list, and labeling all this correctly. Because I did it by hand, I messed up for things, of course, because who can tell? So the way to kind of check myself to see what was right and what was wrong, I spawned in every prototype, and then I got little images here. Wave function, there we go. I got an image for every socket type. If you look, there's actually not a lot of socket types, so that's why I was able to do this hand. There's a lot of prototypes, but in terms of actual types of sockets, there's only like 5 or 6, and then the flipped version of a few of them. Some of them are symmetrical, like the straight one, but a lot of them are both. And then there's 2 types of air, so this is exterior air and this is interior air. And then there's a null one, which is just nothing can go there, which is good. And then I kind of spawn these into the different sides. So if you notice, it has the material to check, and then I just literally went through this and been, is any of these wrong? Let me actually go through and until they all looked right. Let me actually show you what it's spawning in here though. Okay, so this is the grid spawner. It just spawns back and forth all the prototypes for the entire grid based on the data tables. That is, the data tables will import into Unreal as long as you have the data structure. This is the same as the 2D stuff. If something's explicitly covered in 2D stuff, I'm going to skim over it. And then the preview block is this mess here, which looks like this, and it just labels all the directions and spins these. It puts the right thing in the right thing, so it checks the socket type, and depending on what socket it is, it puts the right image into the texture to label it. This is probably the worst part of the system. I'm not going to go over this too much because honestly, just make a script in Blender. I was, I guess, intimidated by that, and I knew I could do it by hand if I just put on some music and just got to work. So that's what I did. But if you want to do this sustainably, you should probably find an automated system to label all these sockets and produce your valid neighbors list. Okay. We don't need this anymore. I'm actually going to close this project since the one we have it working in, actually, we'll keep it open for now, is actually in here. So the cell is not that different from the 2D one. I did remove all the 2D stuff, at least in this exported version in a new project. And I think, let's see, it does one more thing. Oh yeah, this is a mark. This will spawn in a system. So it will spawn in a null cube if it doesn't, if it runs out of options, which happened a lot as I was making this system. Quickly just review the socket tables. You can see how they get imported. The weights, this is just like the grid or the spreadsheet on Google. That's why I like the spreadsheet so much, since and here's the valid neighbors list. Debugging this is kind of a pain, but you can, once you check everything around it, I manually checked it with like that system. It seems to work pretty well because the neighbor rules are actually pretty simple. Okay, this is the actual 3D bit. I did put in a regen system, so this, let's jump in. So if it's generating, I can just press Q and it will start over, which was useful for debugging. Activation system, add all the sockets into a string array. In here, I'm splitting these. I'm making two different lists. I'm making all the objects that work for the ground level and everything that works for things that aren't on the ground. So I don't want any of the tiles that have sand on them in this list. And then I start spawning the grid. This is all like the 2D one, except it uses 3 dimensions, so I have an additional Z dimension there. I did throw in a few more debug features. Let's see. So debug spheres in visible air were quite useful. The spheres are just the circles, just so I can tell if my grid is spawning in correctly at all. Let's turn off the debug. Here, I'll turn off the air so you can just see the spheres. That's the spheres. And then the visible air is like this. So you notice the way I'm doing it, and I'll get into this in the blueprint, is I spawn a layer of air on the outside because I want to beach all around. So that's how I do that. And you can also change the normal stuff like the height. So let's see here. There we go. And there's the interior air. See, that's the green air instead of the blue air. And that's just so you don't want an air block breaking your wall, because then it's going to create exceptions and then you're going to have a hole in your mesh. So just to distinguish between those, that's how it works. I think it runs pretty well. It will, with the current way it's set up, if you make the grid size too big, it reports an infinite loop. So you would want to optimize it with C++ loops in code. Okay, so it spawns the grid, so it collapses the sides with corners. So I go through the grid, I then put air on all these sides. So I just kind of grab like, hey, is it a side? Is it a side? This is very similar to the update generation systems to see if it's the side. And then I just put air into, which is this one right here, into all the sides. And then I spawn in a corner. So if you notice, let's turn off the air so you can actually see it. The first thing that spawns is something in every single corner. See? Oh, and then you can actually slow this down. So, and then it slowly generates. Okay. So that's all this does. So collapse aside and then run wave function collapse, which is right here. We're actually going to fix something. I think for this new system, we destroy these. I'm actually going to get all here. Let's actually do this. This is the recipe system, which I do at the very end, which is checking for pillars. And then I spawn in something here. We are actually going to make this, I think I just call them bits. Yeah. But we want this to actually be a array. And then we're going to add like that. And we're going to clear this at the start. Just so this system, when I reset things, it's going to reset correctly. Okay. And then we're just going to copy this. We're going to do it like this. Since we want to delete both of these, we're going to delete all the cells, but we're also going to delete all the bits. Just like that. Okay, that should work now, I think. All right, let's speed speed this up. There we go. It takes a little bit to start the second layer because it's filling in all the air, but once it gets started, it finishes off quickly. So there you go, it spawns in the bits, and okay, nice. And everything deleted, and it restarts. We just press Q, so that works. Nice. All right, back to the overview. So wave function collapse. There's this new system. I don't think this was in 2D. I call it the propagation cycles. So basically, how many times do you want it to update before trying to collapse a cell again? And this just uses kind of a do-n system here. And then the delay is right after this. If this does equal, what am I doing here? Oh, this is just checking to see if the first layer is done. Where it's like, okay, then once you're done here, go. And it's just kind of using a Boolean, and it's going through all the grid cells, and it's checking to see, hey, are all the base, since it spawns from the bottom up when making the grid, it checks like, hey, is the first layer of the grid all collapsed? If it is, go ahead and say the ground is done. If it's not, they say the ground is not done. Prune cells, I don't think this got weird. Added in the ground versus not ground, check that. Depending on the array index, so it's like, hey, if it's on the first layer, use first layer cells. If it's not, don't. This is pretty similar to the 2D stuff. Mostly I'm just scrolling through this stuff just so you can see, partly for my own reference too, just so I can remember how this stuff works. Skip collapsing if nothing is collapsed. So this goes through, hey, is there anything in the pruned list? If it's not, then go ahead and skip. And then I do have it can only skip things 12 times. If nothing gets collapsed within 12 prunes and there's still uncollapsed cells, then that means something's wrong. This is the same sorter, just we're using the cell list or this list here. I think this was the tile list in the 2D one. Then collapse cell. I moved a lot of the collapse cell stuff to, this is the weighted thing. So what I'm doing is I'm grabbing all the cell options and then I'm just throwing them into a list as many times as their weight says. So if you notice, like air gets thrown into it 10 times, where something like, what's this? I think this is just like the ground, or not that one. Air gets thrown in 20 times, I'm sorry. And then the ground gets thrown in 30 times. I wanted to emphasize that. And these had different weights. And then from that weighted list, it selects something random to collapse. That is something I did here, where these collapsing things I think I had in the actual generator. I just threw them in the cell themselves. I don't have tiles anymore. I just put the geo in the cell. Seems simpler. Partly because the neighbor options are now in here, in this big table. The main reason we had separate tiles in the 2D one is to store all the neighbor options in arrays, but if they're all in a table, you don't need separate blueprints for every single tile. You can just look it up from the table. So that's actually a bit simpler than the 2D one. Well, if you consider a giant neighbors table simpler. And then it collapses that. Okay. It's actually not a lot more. Keep going if the cell is uncollapsed. This is a simple check. I kind of added a way to output if it's actually done. So it kind of starts by opening this thing, and then if anything is uncollapsed, it immediately stops the loop and closes this gate so it doesn't finish. And we're back to the propagation cycles. So like that's wave function collapse. The actual kind of iterative system, so to speak, pretty simple. It's got a lot of pieces and you have to have like all the tables correct, but the actual system is, I mean, pretty straightforward. I think the next thing to do is absolutely, I need to optimize this. Like here, I wonder if I can induce an error. Let me, I think if I make this like 32, it will error out. We will see if this crashes, you know what's going up. Yep, so look, infinite loop. So that's just because it's running on blueprints. For loops are notoriously inefficient in blueprints. So you would absolutely want to make that C++. Other than that, if y'all have any questions, this was just kind of an update. Finally, it's nice to have wave function collapse working in blueprints in 3D and Unreal Engine. If you have any questions, feel free to ask.